Okay, this is Introduction to Statistical Learning, Chapter 12, and we are on question 4 of the conceptual questions here. Okay, so here's the question there, and we're basically given two nearly identical scenarios, and we're meant to answer some things about them, so it's a little bit of a boring question here to look at, but I suppose I will read the entire thing. Okay, so suppose that for a particular data set, we perform hierarchical clustering with single linkage, and complete linkage. So two separate passes at this, one using single linkage, the other one using complete linkage, and we obtain, a dendrogram for both of them. Okay, so let's look at the first scenario. So we have 5 total points here, and 1, 2, and 3 form one cluster, and 4 and 5 form the other. Okay, and so again, we're going to pass over these with hierarchical clustering, one with single linkage and the other one with complete linkage. Okay, and what we are meant to try to reason ourselves through is in these dendrograms, which fusion will occur higher on the tree, or maybe they fuse at the same height, or maybe there's not enough information to tell. Okay, so higher on the tree, in other words, in the single linkage versus the complete linkage. Okay, we'll look at B here in a second, but let's first reason ourselves through A here. So in order to answer this, we have to understand what single linkage versus complete linkage is. And in single linkage, within these clusters, we take all pairwise clusters, so 1 to 4, 1 to 5, 2 to 4, 2 to 5, 3 to 4, 3 to 5, and we take the smallest of these pairwise dissimilarities between the two clusters. Okay. Now, on the other hand, if we do complete linkage, we do something similar, but we take the largest. Dissimilarity measure. Okay, so between these two methods, single versus complete, we know that the one that is going to is more likely to have the smaller dissimilarity is the single linkage. Now, when we think about these dendrograms, let's go find a dendrogram here. Got to scroll up a ways. Let's use this one. If you look at the y-axis, is the dissimilarity, and it goes up as you go up the y-axis, right? So if we go up higher, that is more dissimilarity. Okay, so if we apply that to here, this would imply then that the single linkage would fuse these two clusters lower on that y-axis compared to complete linkage. Okay, so the answer is that probably single linkage will link lower, will fuse the clusters lower, and complete linkage will fuse them higher in the dendrogram. Now, I think that the most accurate answer, though, is that it could be that all of these pairwise dissimilarities between cluster 1 and cluster 2 are equal, in which case the smallest and the largest are equally large. And so there's not enough information to tell, although I'm not really sure that you could get clusters, two distinct clusters. Well, no, I guess that you could. Never mind. Sorry. Yeah, you could have 1, 2, and 3 be small dissimilarity, 4 and 5 be small dissimilarity, but the pairwise between the two all be the same. So yeah. So I think that technically there's just not enough information to tell, although it's probably complete linkage that joins them higher. Okay, so now for part B, we're meant to answer basically the same question, but now our two clusters consist of single observations, observation 5 and observation 6, and we're meant to answer the same thing. Well, now we know that they're going to fuse the two methods, single versus complete, are going to fuse at the same level. Why? Because there's only one observation, so there's only one pairwise comparison, and that pairwise comparison is both the smallest and the largest dissimilarity. Okay, that is it for this one.